Hello there everyone. In this video, we're going to talk about the Fibonacci sequence and how to implement it in Python. So, everybody knows about the Fibonacci sequence, right? It is named after the Italian mathematician known as Leonardo Fibonacci, and it is a pretty interesting sequence, which starts from 0 and 1, and every other number in the sequence is just found by adding the previous two numbers. So if we have a Fibonacci sequence in here, and as I said, it starts from 0 and 1. So every each number after this is found by adding the previous two numbers. So 0 plus 1, you get 1. So then it's 1 plus 1, you get 2. And then 3. And then it's 5, so just 5 plus 3, 8, 8 plus 5, 13, and it just goes on now up to 21, and 34, 55, and like that. So this is actually the Fibonacci sequence. This right here is an example of the Fibonacci sequence. So we will define Fibonacci sequences Fibonacci sequence in two ways. We will make two different functions for the Fibonacci sequence. So one is right here, function for finding the nth Fibonacci sequence number. Okay, the nth. This is really important, the nth Fibonacci sequence number. So this function that we're about to define will give us the nth Fibonacci number. And we will define one more, which will give us, the whole Fibonacci sequence up to desired end point. Okay? So the first one. So let me explain what do I mean by the nth Fibonacci number. So if you get back to this Fibonacci sequence of ours, so starting the count from 0, nth, first 0, right? So the first number, the in the Fibonacci sequence, okay, it's 0, but we call that, the number 0, right? So then 1 gets 1, like this. And this one will get the second number. This 2 gets the third, right? And this gets the fourth. Sorry. And the fifth number is 5. The sixth number is 8. And it goes on like this. So the ninth number is 34, for example. And the 10th number is 55. So this is what do we mean by the nth Fibonacci number. So let me just write in here. This is the Fibonacci sequence itself. Let's get it. Let's use short names. And this is, the fib nth number in a sense. Okay, the count. So if I say the third number, so it's 2, right? Like this. 3 is 2. 3 is 2. And if I say the fifth number of Fibonacci, that's 5. And if I say, the ninth number, that's 34. Or if I say, the 10th number, then that is 55. So this is the Fibonacci sequence itself. And this is what do we mean by, the nth Fibonacci number. So this first function that we are defining will give us the nth Fibonacci number. It will take an input like fib of 10, and then it should return 55, right? So my keyboard is blocking it a little bit. So look at function for finding the nth Fibonacci sequence number. So I should give the number. So we should feed the function with the desired nth number, and it's gonna return the Fibonacci sequence number that corresponds with it. So if I give it 10, now I should get 55 back, right? So let's just go and define this function. So let's say I'll call this define. So as I said, we will define two functions. So I'll just call this fib and call the next one fib sec, something like that. Okay, so define fib and n. So n is like, it just stands for the input that we were gonna give it. So we will give it. So define fib n, and next line. So as you see in here, if the n is 0, the output is 0. And if the n is 1, the output is also 1. So we can say if n equals, pay attention, equals, we mean the comparison operator equals, not the assignment operator, the single equal sign. We mean the double equal sign. So if n equals 0 or n equals 1, so what should the function do in this case? It should return n, right? I mean, it should return n, whatever n we give it. If we give 0, it's going to return 0. If we give it 1, it's going to return 1, and that's exactly what we want. So if n equals 0 or n equals 1, return n. And then I should also say else. So we're just doing a two-way conditional statements, if else block. So if that happens, do that. Else, if that doesn't happen, if n is neither 0 or 1, so do this. Return fib n minus 1 plus fib n minus 2. Yeah, that's how we should do. Return fib n minus 1 plus fib n minus 2. So what happened in here? So the function itself is fib n, right? So this is the function that I'm defining. And within the function, and I've come here and I've recalled the function that I'm just defining. So this instance is called recursion. What has happened in here is recursion. Fib is a recursive function. So recursive function is a function that calls itself. So that's exactly what fib is doing here. If fib is, if n is 0 or 1, it's going to return n. If it's not, the function will repeatedly call itself until, it's going to say n minus 1 plus n minus 2 until it reaches 0 or 1. So this is called recursive function. So whenever we have recursive function, there are a couple of things to pay attention to. 3 points more specifically. We should have a base case, which means when to stop. Okay, a base case tells the function when to stop. And we should have a recursive case. So, recursive case. So let me put it this way. This is a recursive function. It calls itself repeatedly. So it sure has a recursive case, right? So we have a recursive case that calls itself again and again. So whenever we have a recursive case, we should also have a base case, that will tell the function when to stop, when it's enough, when to end, right? If we have a recursive case that just goes on and on and on and on, then that's a problem, It will go on and it will hit the maximum recursion length that Python allows, which is by default 1000, and it's just going to bring up a recursion error exception and nothing's going to happen. So that's why whenever we have a recursive case, we should also have a base case, which tells the function, when to stop and when it's enough, right? So that's exactly what's happening in here. So it's going to add the previous two Fibonacci numbers, right? And give us the nth number. So like if I want the 10th number, it's so simple. This function will add the 8th number and the 9th number, right? So it just calls itself repeatedly to find the 8th and the 9th and then add them together to give us the 10th, which is 55. So in this case, we should have a base case. We will illustrate this in an example, and analyze the stacks that are going to take place. So we should have a recursive case. That's 1 point. As I said, 3 points, right? So we should have a recursive case. It's a recursive function, right? And we should have a base case that tells the recursive case when to stop. And the third point is, the recursive case should lead towards the base case. So look at in here, we are saying fib n minus 1 plus fib of n minus 2. So slowly this n will break down, right? This n will break down, and n will finally reach 1, and that is exactly the base case, and it's just gonna return n and add all those numbers and give us the nth Fibonacci number. So the recursive case should lead towards the base case. So if I say fib n plus 1 plus fib n plus 2. So we're never going to reach the base case, and then the recursion will go out of scope and done. We'll not get anything. So whenever we have a recursive case, we should also have a base case, and the recursive case should lead towards the base case. So this is exactly recursion, right? Recursion means, breaking down a big problem into smaller instances of itself, and solving each instance one by one in the lead up to getting the final ultimate answer. So that's recursion, and this is a recursive function. So fib in here is a recursive function for finding the nth Fibonacci number. So this is it now. Our function is ready. So now we can go ahead and use it. So, if I say, so the function says print, return, so I should say print, right? So print fib of 10. Print fib 10. So I give it the input 10. So it just analyzes, and so it just gets n. Okay, so n is 10. It gets here, it starts the work. So if n is 0 or 1, return n. So it's not 0. It comes down here and starts the recursion. It goes on and on and on and finds the previous two Fibonacci numbers, adds the 8th and 9th numbers that we have, 21 and 34, and it will give us the 10th number, which is 55. So, if I go ahead and run this once, let's see, and 55, as you saw. So, let's just say 8. So, 8, this should return 21, right? And right. And what if I say, 5? It should return 5. And that's right. So, let's analyze it with, this part. If it's 0 or 1, return 1. So if I say 1, and I get 1. So that's right. That's correct. This is exactly what's happening in here. So as I said, we will analyze the stacks once. So to do that, let's just consider a smaller example. Fib of 5. Okay? If you go with bigger example, it's just going to be so difficult. So whenever we pass 5 to the fib function, so this is what happens, right? It goes in here and it analyzes that n is not 0 or 1, so it comes down and implements this part, right? So it's gonna say, in the first run, okay? So I'll just show it like this. So it's gonna say fib n minus 1 plus fib n minus 2. So it'll be fib 4 plus fib 3, right? So, and the next run is just going to go back and analyze each one of these. So fib 4, it's 4. It's neither 0 nor 1, right? So fib 4 will now turn into fib 3 plus fib 2. Okay? Fib 3 plus fib 2, as we know in here, right? Fib n minus 1 plus n, fib of n minus 2. And then fib 3, on the other hand, will turn into fib 2, fib of 2 plus fib of 1. So here you go then. We reached the base case in at least one place, right? So if we keep it going, right? This is why it gets really complicated if you go on with, very big numbers. So fib of 3 will get fib of 2, as we saw in here, right? So fib of 3 will get fib of 2 plus fib of 1, and fib of 2 itself will get, I should just write it a little away like this. So fib of 2 will get fib of 1 and fib of 0, right? So everything is going right. I hope you've paid attention to the stacks and how we're developing this. and how are things going. So this whole thing is now just this first part of us. Okay, so Feb3, the Feb3 gets Feb2 plus Feb1, and the Feb2 gets Feb1 plus Feb0. So look at, we're reaching base cases slowly. And then on the other hand, in here, so as you can see that, okay, so Feb2, as we saw previously, right? In here we had Feb2, so now in here we have it again. Feb2 again gets Feb1 plus Feb0. So I would just, let's go to the next line because of the keyboard. So plus Feb0, and Feb1 is exactly where we reach the base case. So look at, if you give the function Feb1, it's just going to return you 1. Done. So I think we should go once more. And the next time, so this Feb2 should still, I mean, it's still big, right? It's still not that small to be eaten in one bite. So you should slice it down and break it down into smaller parts. So this Feb2 will also become Feb1 plus Feb0, and Feb1 plus Feb0. Let's just write them together. So this Feb2 right here becomes Feb1 plus Feb0, and after that, we have that Feb1, which returns 1, another Feb1, which returns 1, and a Feb0, which returns 0, right? So let's just integrate the two parts. This Feb1 will also return 1, right here I'm talking about, and this Feb0 in the next line, line 16, will return 0, and we have a final 1. So here we go then. This Feb1 is also going to return 1. So the Feb0 will return 0, and I just write a 0 instead of that. And here we go then. We have broken the function into smaller parts and analyzed each small part, and every small part till the point that we got to the final ultimate answer. So what do we have in here? It's 1 plus, so leave the zeros. How many ones are there? 1, 2, 3, 4, 5. We exactly have 5 ones, and this equals 5, and it's clear that when I say print fib5, it's gonna return 5, right? So let's just comment this area. Let's use doc strings to comment them all at once. So if I say print fib5, as you see here, right? Fib5 is 5. So, and we analyzed all the stacks and also got 5. So when I run this, yes, fib5 is 5, and that's for sure. So this is how the function for finding the nth Fibonacci sequence number goes. Okay, so let's clear all these stacks that we have created in here. Let's just cut them out. So we talked about the nth Fibonacci number, Fibonacci sequence number function. So let's get to that other function that I talked about. So this function, as you saw, you give it an input number and it returns the Fibonacci sequence number in accordance to the position that you give it, right? So maybe the number that you give is like the position. I mean, give me the 10th Fibonacci number, the 9th, the 8th, something like that. But this other function, this function generates a Fibonacci sequence from scratch. So, I mean, it starts from 0, 1, and then all the way till the endpoint. So this is a little different. That function gave you the nth Fibonacci number. This function just starts the Fibonacci sequence and goes up to a specified point that you say. So I'm going to call this function, let's say def, and I'm going to call it fibsec sequence, Fibonacci sequence, right? So to find fibsec, and we'll give it an input similar name, n argument, I should say, a parameter, and a parameter by, in time of definition, you call it n is a parameter. So then you give it a value and it turns into the argument, right? So we give it the parameter n, and this is the input, the input number that we give to the fibsec function, and it is the number until which the Fibonacci sequence should run. Okay, it is the number until which the sequence should run. So I'll go through this a little quickly since the video is getting too long. So this is how you define it. Okay, so you say, AB equals assignment 0, 1. So we're going to use a while loop in here, the conditional iteration, entry control loop, the while loop. Okay, so while a is smaller than n, okay, while a is smaller than n, do these. While a is smaller than n, do these. So first thing first, print a and end it with a space. If you do not say end, the print function defaults to end with a new line. So I want to override that default by saying end it with a space, right? To keep all the outputs on the same line rather than going to new lines and all. So print a, end with a space, and a b equals b a plus b. And done. Our function is ready. This is the function which accepts an input number and gives you the Fibonacci sequence from 0, from scratch, from the very beginning up to that number. Okay, so the number in here we showed with the parameter n. So if the number n is included in the Fibonacci sequence, so then the is included in the Fibonacci sequence is a Fibonacci number itself. So it will start from 0 and go exactly up to that number. So if that number is not included in the sequence, this will print the sequence from 0 all the way to the number right before that. Okay, so let me just give you an example. So if I say Fibonacci of 10, right? So in here, when we said Fib 10, it would have given me, the 10th Fibonacci number, which was 55. But in here it's different. What I'm saying to this function, if I say fibsec 10, this means that give me the Fibonacci sequence up to 10. Start the Fibonacci sequence and go up to 10. So if 10 is included, so 10 will also be printed. If 10 is not, it will stop right in the number before it. So it will start from 0 and go up to 1, 2, 3, 5, and 8, and then that is exactly where it will hit the roadblock, since the next number is 13, and that's bigger than 10, so it will stop at 8. So this is what this function does. So let's just see once. So keep in mind that the function has print, so I don't need to print again, and just call the name of the function. So let's just compare, and there we have print. Let's just change this to 10, print fib 10, and in here I'm just gonna say fibsec 10. Okay, fibsec 10, and let's just see the difference. The keyboard causing problems, so let's just run. And here you go, as expected. So fib 10 gives you the 10th Fibonacci number, 55, and fibsec 10 starts the Fibonacci sequence and runs until 10. If 10 is included, yes, it will print it. If not, it will stop right before 10 in the number right before 10. So that's exactly how the function is working. So you can go through the stacks of the function yourself, and just like what we did before with fib5, but if I just give you a quick example. So what's happening in here is that in here, this is the important point in this function. This is called multiple assignment. Multiple assignment. So no, multiple assignment. So we used to say a equals 10, a equals 20, right? A equals sign 20. That's regular typical assignment in Python. But in this case, this is a multiple assignment. So in here I'm saying AB equals 0, 1. So this means that A equals 0 and B equals 1. respectively, by respective order, by positional order, right? So if I just quickly give you a little indication of how this function works, so what happens here is that A and B keep trading values. A and B keep trading values. The function starts with this. A is 0, B is 1. So those are the very first two numbers of the Fibonacci sequence you see here, right? So in every run, you can see in here, A has the first value and B has the next value. So in every run, B gives the next value to A and gets the value after the next value for itself. That's what's happening. So if you've seen TV shows, if you're into seeing shows and all in TVs, so they all always say like now, the show that's playing now, and then we have next, and then later, right? So in this case, B has the next value. So in every run, B gives the next to A and gets the later for itself. Then gives the next to A and then gives the later for itself. So A also in each run takes the next value, prints it, and then takes the another value and prints it. So if we run through this very quick, so in the first run, it's like this. A is 0, B is 1, right? So it comes here. So if I say, well, A is smaller than N. So let's say if I gave a little bigger N, just like 10, right? So if A, the conditional iteration, right? So if this is true, then it goes on and executes these things. So, well, A is smaller than N, then these things happen. A gets printed and a space, and then AB equals B, A plus B. So A is 0, B is 1. So 0 is printed, the first number is printed, and then A gets the value of B. A becomes B, and then B takes the value of A plus B. So you got the point, right? A gets the next value, and B gets, the later value, the value after the next value. So which is 0 plus 1, and again 1. You can clearly see in the sequence too. 0, 1, 1, right? So in the next run, so A is smaller than N, so in this case, it's 1, 1. Okay? Both A and B are 1, as you can see. So both of them are 1. So in this case, A gets the value of B, once again, which is 1, and then B gets the value of A plus B, which is 2, right? Exactly like that. So you can clearly see in here, right? So this 0 gets printed, then this 1 gets printed, and then the other one gets printed. And now the value of 2 is in B. So in the next run, once again, when A is 1 and B is 2. So this is this part of the code, right? It comes here, A is again smaller than N, so it prints A, it prints 1, it's the second one, 0, 1, 1, right? And then this happens. A gets the value of 2, and then B becomes 3. And then in the next run, when A is 2 and B is 3, so now 2 gets printed by A, this part right here, and then A gets the value of 3, well, B jumps to 5. So that's exactly what's happening. It just goes on and on like that. So we can just go more within the stacks as long as you want, right? So 3, 5, they just keep exchanging values. So in this case, now this 3, 5, now the code runs with 3, 5, right? So A is 3, B is 5. 3 gets printed, and then A becomes 5, and B becomes 8. And then in the next run, when A is 5, and B is 8, so 5 gets printed, and then A becomes 8, while B becomes 13. So let's say we're talking about the fibsec 10 that I didn't want to go this deep, but Okay, so 5, 8, 8, 13, right? So the next one, A is 8, B is 13. A is 8, B is 13. So 8 gets printed, remember, right? A is smaller than N. So N is 10, right? So A is 8, A is smaller than N. So A gets printed, space gets printed, and then A becomes 13. A takes the value of B. B takes the value of A plus B, 21. So A takes the next value, B takes the later value, right? So now in the next run, this is where we stop. A is 13, B is 21. So when it comes here, while A is smaller than N, do these. So A is not smaller than N now. A is 13, N is 10. So this is where we hit the roadblock. This is the time to stop. And then the function stops, no more values get printed, and we are returned with exactly what we saw moments ago. From 0 to 8. Yeah, exactly. And this is how this function works now. Yeah. So in this video, we learned about Fibonacci sequence and two different functions. One that gives you the nth Fibonacci number. As you can see, we defined it like this. You give it an input value and gives you the nth Fibonacci number. I mean the 10th, the 50th Fibonacci number, right? And then this function right here that generates the Fibonacci sequence from scratch and goes up to the desired target that you give. So if that's included, it will also be included. It will end right at that point. If that's not included, it will just end in the number, in the Fibonacci number right before that. So let's just run this again with 50s. And oh, so the point is here that Fibonacci 50, this first function, this gets a little difficult to calculate probably on the phone, and that's why it snaps and it just does not bring any value. So let's just say fib 20. And it's also a recursive function. Do keep in mind that recursive functions are, not that easy functions. They're not that easy on RAM and the processor. So with all the stacks that take place, you saw, right, in the examples. You just work fib 5, and in here just fibsec 10. How many stacks are there, right? So that's a good point to keep in mind, that these functions are not like easy functions, and they're not going to be easy on the processor. So that's how you saw, fib 50 it just couldn't handle it, right? So this was easy to handle. And yeah, so that's the 20th Fibonacci number. Look at the 10th number was 55, but 20th is that much, so 50 just gets much recursion and iteration. So, and there we go. Then if you want to go to fib 55, 50, I think it said, yeah, fibsec 50. So we know that 50 is not included, yeah? We have 34, then it's 55. So it stops at 34. And let's just end this video with a fun fact. If you're into football, this is going to be a very good example. You know that Lionel Messi just won his 8th Ballon d'Or, right? And his 8th Golden Ball. So if you just say fibsec 10, run the Fibonacci sequence until 10, so it stops at 8, right? I'm talking about this output. And if you say, let's just comment this out. And if you say run the Fibonacci sequence until 7, which is Cristiano Ronaldo, another legend of the game, he has won 5 Ballon d'Ors, right? So if you run this, it stops at 5. Wow, what a coincidence, right? Good point to keep in mind. So these were the two Fibonacci functions that we talked about. The nth number Fibonacci function, right, this one, and the Fibonacci sequence generator. It generates a sequence from scratch until the desired target. So goodbye and peace out.